I'm happy to have on stage an Italian speaker. So please, big round of applause for Maurizio Latini. He's a web developer at European Center for Medium Range Weather Forecasts.
Hello, everybody. It's nice. I'm actually from Firenze, so it's nice to be back home for a while after more than 1 year in UK. So I'm coming from the ECMWF, and just as a small survey that our director is always asking us to do it when we are going to present something outside. How many of you have heard about ECMWF? Okay, just, okay. And how many of you have an app on your mobile who's using weather forecast? Okay, almost everybody. So it's more likely that the data that your app is using is coming from us. So what we are doing, we are an independent intergovernmental organization. It's born in 1975 with 22 member states plus 12 cooperating states. So it means that we are Europe international, more or less. So we are UK-based, but we are not UK, luckily. And what do? We are doing weather forecast. We are 4 years old in 2015. We are 280 employees. We have a budget of over 55 million pounds, so which is quite a big budget. And we have a commercial license in over 29 countries. And we found a lot of researches with this budget. Plus, we are doing research ourselves. So, as I said before, we are doing weather forecast. And our current strategy is to developing the core forecasting system for other projects to be used, for example, for forecast of severe weather, high-quality near-surface weather product, atmospheric composition forecast, climate change monitoring. So basically, we are aiming to provide a whole range of products that can be used in a scientific environment, can be private or public. One of these projects that is running in joint with under the umbrella of Copernicus is called EFAS. What is EFAS? EFAS stands for European Flood Awareness System, and is founded by the EU. And as I said, it runs under the Copernicus EMS, which stands for Emergency Management System. And what is Copernicus? Copernicus is a set of satellites that are providing images for the Earth observation and for pretty everything. We are using this for launching this European flood awareness system. What is it? It can happen that during a flood event, in Europe there are a lot of major rivers, for example the Danube, which is transboundary. So it means that if a flood event occurs, it can hit different countries. So that sometimes this difference between responses between different countries can lead to incoherent decisions during a flood event. So what was the principal idea of the European Commission? Was to establish like an early warning system in which we can send weather forecast up to 10 days and to the local authorities. So in case of a flooding, there can be like a coordinated response instead of having like different responses at different time. So what is EFAS? It's an early probabilistic flood warning system across Europe. It's operational since October 2012. What does it mean operational? It means that twice a day we provide weather flood forecast, so at 00 and at 12 every day, to the partners. We have more than 50 partners and more than 500 users. The information, it's access restricted, so it means that only the partners who has undertaken like a registration process and everything can see the actual real data. We provide some historical data for research and as case studies, but the actual data at the moment are, because EFAS is composed by different organizations, and they didn't want to share the public data, it's password protected, and it's not possible to register on site at the moment. We are planning to change this. How does it work, EFAS? EFAS is getting a bunch of data, like historical data, statistical data, European data layers, and weather forecast, generally, like the ensemble ECMWF, plus other weather forecast models. We input all this kind of data inside an hydrological model that is called LeafSflood. It was a Fortran program model. Now we have changed it to Python. And so twice a day we are running the LeafSflood model, and we produce this kind of weather flood reports. We have a team of forecaster that, based on the generated reports, reads the report itself and decide to generate alerts and to send to the local civil protections and to the EFAS partners. We can generate 3 different types of alerts, and this is, okay, this is not the focus of the topic, but anyway, this is how the system itself is. Since we are running it from the 2012, we are continuously adding new products to EFAS, and I'm slowly coming to the LeafSflood, to the database, we are adding new products because for research for research objectives, and we want to keep our users, we provide them with a variety of products. One of the latest, for example, is this nowcasting radar that is based on composite radar images. It covers the whole Europe. It's generated every 15 minutes, and it's a huge amount of data. Every hour we have 100 gigabytes of data, and it holds the forecast for the next 8 hours. So every 15 minutes you have the forecast for the next 8 hours. Other products that we are delivering are this flash floods indicator. And sometimes when a flood event occurs, then we use it as a test project to show to the more hydrological conference. I'm not the hydrologist, I'm the guy who's doing this map and these reports, but I'm not an hydrologist, so I cannot read I can read the hydrograph itself, but I cannot really explain how is it working. Together with EFAS, we also running GLOFAS, which is the same as EFAS, but it's global. So at the same time, when we are running the LeafSflood, the models for the European we are also running the model for the whole globe. What is the main difference between EFAS and GLOFAS? GLOFAS is free, so everybody can log in and get access via Facebook, via Twitter, via LinkedIn, whatever, because it's not showing the same data as EFAS. So EFAS is showing data from Europe, and our partners in Europe doesn't want to share their data. GLOFAS is more worldwide, so you cannot see data of Europe, but you can see the data for all over Europe. So sooner or later you will see also data from the UK as well. Okay, now it's slowly coming to the since we are always adding new products to EFAS and GLOFAS, we decided that, we were asked by the EFAS community to create a database for storing flooding events. Because current historical database has a sparse coverage, and sometimes they are missing data and whatever. So what we decided to do, we founded a project under always the Copernicus umbrella, and we hired some people outside from the ECMWF and JRC, these guys from the flood list, and basically what they have done, they are collecting all the information coming from different sources, from Twitter, from all these kind of social networks, and they have built a database of historical flooding events. And okay, this is really important because everybody knows about major events. For example, the one that is happening now in Colombia, if I'm not wrong. If I heard it yesterday on the news. But sometimes the flash floods are really local and they don't get too much coverage on the news. But it's really a good information that for researchers are really important. So we asked this guy to create like this kind of database, and they did a good job. So they are storing historical information since 2008 onwards. So starting from this point, they provided us an API. So every day we are running a Python process that reads through the API and feeds an internal database inside the ECMWF, which we are then adding some other content to it. So as I said, okay, we have this scheduled work that runs every day. How is our architecture? So I said we are in a Django conference, so it's time to talk a little bit about Django. We are using Django in a kind of like lightweight. It means that our Django stays inside this orchestrator layer. So it means that Django does not the heavy lifting way. It's more like a schedule. It's in between a scheduler and just it doesn't do too much. It's basically it receives a request and then it delivers to this orchestrator. The orchestrator runs can query different database, different data structure, different. Basically, we can plug everything that we want inside this structure. If we don't have the Python service that does it, we can write. As an example, for the one that I was showing before, the radar data before, we weren't able to use netcdf before to display it on the web. We wrote a Python service and then we are displaying it. So Django is it's like a lightweight. We are using our own API. We are not using at the moment the REST framework. One of the future development is to integrate our Django with the REST framework, but at the moment we are writing our own APIs. So how does it work? We have a WebJS interface. We request the data. The data is handled by the Django view. The Django view invoke the retrieving service through the orchestrator. The orchestrator is calling the Python services that queries the database and return this time a GeoJSON object, because the database that is the API that is provided to us is not a geographical API, so we creating a GeoJSON object, and we simply pass the GeoJSON object then to the Django view, and the Django view provided to the WebJS itself. So this is the interface. This is a beta release of the interface. So it's how does it work? We present the heat map. So the heat map is like the representation of the events all over the globe. And based the more darker the color is, the more events are located. So if we translate it in events, you see that this has, I prepared this presentation like last Friday. So this is this is 4 days old. So probably now that there are more events because of, for example, there is the one in Colombia, and so this is how the interface is. It looks like. So we decided to assemble the whole points in smaller groups, so we don't have the scattered image of the events. As soon as we zoom in, we are getting more atomic views of the events, and we can identify single events. We provide just a small information of the event itself, so when it started, when it ended, if there is a name, and we can have more information if we just go to the single event itself. So we have the geographical location, plus the other information that are used to the research. Plus, if there are available, we can have some links to the local websites where the event is located. This is one that was here in Pistoia. It was really close to Firenze. There is another one in Nigeria, the region. So basically, we are collecting events all over the world, and the process is the same. This comes from the flood list example. Of course, we can filter the events. We provided a filter for the database itself, so we can query the geographical interface itself, or we can filter the database and have the result of the filtering simply displayed on the map. So in this case, I'm filtering for a flash flood type, and I'm getting only the events that are related to a flash flood event. I can do further filtering. So if I want to restrict the area, I'm going this time to Europe. So I'm getting only the flash floods events that are related to Europe, and so on and so forth. So if I'm going to Italy, then I can see that in Italy from 2008 onwards, there are only 6 flash floods events, and so on. And then I can get the details of the events. I think it's... So why did we decided to ingest this, to create this database? Because for studies on the risk assessment and to calculate maybe the exposed population, it can be useful, because at the moment, as I was saying before, there aren't too many flood events database that are really have this kind of coverage. Of course, we are facing some problems and we have some future developments to do. First of all, we need to normalize the structure of the database because the same event that comes from the social network can be described in different ways. So at the moment, we are hosting events that are more or less the same. For example, flash flood or flash floods. These are really easy to let's say, to clean it up. But we need to come with a more normalized structure of the database. Then, what do we want to do? We want to integrate this one in the new release of EFAS and GLOFAS. EFAS is a project that started in 2012, and at that time we weren't built it in. It hasn't built it in Django. So at the moment we are rewriting the whole EFAS and GLOFAS stack to take advantage of Django and our ECMWF web stack. At the moment, EFAS is running on Joomla and map server, and it's not really. Then another thing that we would like to do is to create a report flood events through an online form, so registered users can insert their own flood events. And another thing that we are trying to do with this is to use this common to use the CAP, it's the Common Alerting Protocol, to exchange information about floods. The Common Alerting Protocol is a general format that has been used during some risk event, some hazard emergencies, and it's really used to exchange different warning from different systems. It's basically it's an XML data structure. And okay, this is all. And I would like to thank you for the attention. And if you have some questions, I would be happy to answer.
Thank you, Maurizio. We have quite a few time for questions, so please line up.
Hello, I really enjoyed the talk. Thank you very much. I'm from the UK, and we've had floods in the UK. And our Prime Minister at the time decided that one way to solve this was to have a hack day about floods. I'm not sure that's the best.
We hosted
you hosted it, right?
Yeah.
Is this common? Does this happen in other countries as well? Or are we just the only people trying to do something silly like that?
Well, okay. First of all, we have no. Even if we are UK-based, we have no jurisdiction on the UK flooding because it's the UK, it's the Met Office that is. So we are always in conflict with the Met Office itself. The hackathon was organized by us from the EFAS because we organized quite a few. Actually, it's a topic that I would like to share with you because we are organized a lot of hackathons. We had one month ago about open data. So if you follow us on the ECMWF website, you will find information about. We are planning to host another hackathon next year, so probably yes. But yeah, this is not a problem for solving, for sure, the flooding events. And okay, UK is really prone but. It's a more Met Office related stuff because they don't want us to play in their own garden. So they are supporting us, but at the same time they are challenging us. Okay, thank you.
Thank you, Maurizio.